Hello everyone, myself Manish and my team will be presenting on neural style transfer. This is the outline of our presentation. So in neural style transfer, we have two inputs. One is content image and the other one is style image. So the problem here at task is that we have to apply the style image on the content image so that we can get the generated image. The original paper was published by Leone Gattis and others in 2016. And some of the application for this can be gaming, artificial art, and virtual reality. So the baseline model uses a pre-trained VGG19, and for the content representation, it extracts layers from an intermediate VGG layer. And for the style representation, a new feature space was built that captures the style of an input image on top of the original VGG representation. When we talk about the loss function, it has two components, which is content loss and the other one is style loss. The content loss captures the difference between the content image and the generated image, and the style loss captures the difference between the style image and the generated image. Next, Danish will be talking about the loss function.
The content loss between the output image X and the content image S, P, is simply the squared distance between the layer outputs for each image for a chosen layer. The style loss between the output image X and the style image A is the squared distance between the gram matrices for a chosen set of layers of these images, with a weighted average being taken over these layers. For our application, the content loss is taken between a single layer of the VGG19 network, whereas the style loss is taken over a subset of the intermediate layers of the pre-trained VGG19 network. Next, Prerna will speak of the tasks and the data set we've used.
So here are the list of experiments we performed over the course of this semester. First, we implemented the baseline paper where the authors performed neural style transfer on images. Second, we extended the idea to videos. We basically did frame by frame inference in this part. So we also tried out a pre-processing technique, which was histogram matching. Lastly, we also experimented with initialization process, wherein we tried to use previous styled images as the starting point for the next frame's iteration. As for the data set, for baseline implementation, we needed a style image and content image. Style image can be any famous painting like the one shown in figure 1. As for the content image, since we were using videos, we used each frame in the video as the content image. Figure 2 here shows a sample content image. These are some of the style images that we used for our experiments. Now Anjani will be discussing more about the results.
This slide shows the baseline implementation results as applied to a single content image. As you can see, the output image's style is now similar to that of the style image, which is a painting. This slide shows the intermediary steps which the content image goes through before the final result comes out. You can see that as the image proceeds over the iterations, it gets closer in terms of style to the painting. This video uses a standard VGG model to style the video frame by frame. The image on the right is the stylized image, whereas the image on the left is the original image. And the style image used is a painting, Pillars of Creation. This video stores neural style transfer using the same VGG model, however, with histogram matching. You can see that the colors are a bit more representative of the original content image. Again, the original video is to the left, whereas the stylized image is to the right. This video shows the same neural style transfer. However, the initialization of the image is done using the previous stylized output. Hence, you can see some lag. This is because the style may be correct, but the content differs. Conclusion and future work. So the initialization of the image at each frame with the previous styled frame makes the motion of the video appear laggy. There is also a greater degree of flickering in the resulting video. This initialization scheme does not work well for videos with a large amount of movement. In terms of future work, you can add a loss term to improve the temporal smoothness of the output video as presented in Ruder et al. In 2016. Thank you, everyone.